So in this video, we are going to look at task 16, translations, which is on page 21 and 22 of your packet. So a translation is another name for a slide. And so we're just kind of sliding the figure up and down or both ways. And translations are examples of an isometry. Again, an isometry means that after we do the transformation, the figure is the same shape and the same size. And for a translation, we need a directional arrow or a vector to define the translation. So we say, just for again, with an isometry, we say that a translation preserves the length of the segments, the sides. And the angles, okay, which means they don't change. They're going to be the same in the image and the pre-image. So for vector notation, we have one of two things. And your homework's going to kind of do different ones interchangeably. So they had this T, and then vectors written like this, where it has these triangular brackets instead of like the parentheses we're used to, and that means it's a vector. And this means translate the pre-image. The first coordinate again is always X. So it's X units left if the value is negative, right if it's positive, and Y units either up if it's positive, down if it's negative. The other notation that is often used is they'll say like translate XY to be like X, and then they're going to put like plus or minus a number. And Y, they're going to put plus or minus a number. So for example, if it said X, Y, and then they had arrow like X minus 2, Y plus 3, what that means is we're moving each point. And so this one is we're doing minus 2 to the left to the X value. And so remember, X is left or right. So if I'm moving minus 2 on the X value, I'm going left. So I'd move each point left 2. And then with the Y coordinate, it always tells me up or down. If it's positive, we're moving up. If it's negative, we're moving down. So plus 3 would mean we're moving up 3. Okay, and that's what that notation means. Or they might write it again like this in vector notation, and that means the same thing. Left 2 and then up 3. Okay, so I'm going to do questions 1, 2 in this video. I'm going to make a second video of question 4, and then you are going to do the rest, or we might do them in class. We're just going to depend it on time. So for question 1, we have the same design, use design 1, and translate that X plus 4, Y plus 2. Okay, and again, what this is saying is this 4 goes with the X value because it's plus 4. It means I'm moving right 4. This 2 goes with the Y value because it's plus 2, we're moving up 2. Or by the vector shown here. So on the packet, they write the vector to show you. So this is the start. This is how we want to end. And so they're showing like we're moving 1, 2, 3, 4, right 4, and then it's going up 2. And you'd have to move every single point this direction, that vector. And we're going to complete the table below to show the coordinates of each of the points after the transformation. So what we do is we start with our pre-image. We take each point. So if I do A, and I'm going to count how we said, we're going to be going for each point right 4. Okay, so that first number is always with the X, and it tells us right or left. And then up 2. That second number is with the Y, and it always tells me up or down. Again, positive means if it's the X value, I'm going right. If it's the Y value, I'm going up. Negative means left for the X value and down for the Y. So I take A, and from that point, I count this. So I'm going to count right 1, 2, 3, 4, and then up 2, 1, 2, and make my new point A prime. Okay, and so that distance between A and A prime, if I drew that like line, it should look like this vector, and that's a vector. Okay, and I'm gonna do the same thing for all the points. So H, I'm gonna move right 4, 1, 2, 3, 4, and then I'm gonna go up 2, and then that's my new H. And I do that for every point. So B, I'm gonna count from B, and I'm gonna move right 1, 2, 3, 4, and then I'm gonna go up 2, 1, 2, and then make my point for my new B. C, I'm gonna go right 1, 2, 3, 4, and then up 2 to get my new C prime. D, right 4 from D, and then up 2. E, right 4, and then up 2. F, right 4, and then up 2. So I'm doing this for every single point, and I'm going to connect these so I don't get lost about what I'm connecting. So A to B, B to C, C to D, E, F. Okay, and then G is here. G prime, this is F prime, E prime, and then I would connect again to H. Okay, and so then I'm going to write the coordinates. So I have A is 6, 4, so A prime, sorry, is 6, 4. I have B prime, which is at, it looks like 8, 7. Sorry, I'm looking at H, not B. B is at 6, 10. C prime is at 5, let's see, no, C prime is at 9, 10. Okay, and so let's again pause and kind of look how we get from one to the other without graphing it. So we took A at 2, 2, and we moved from 2 right 4. And so if I take 2 and I add 4, I get to 6. And then from that point, I went up 2. And so if I take my Y value and add 2, I get 4. And so what I'm doing is for each point, if I didn't want to graph it, is for each point, I'm taking this X value and I'm adding 4. And then I'm taking this Y value and I'm adding 2. So like here we did 2 plus 4 is 6 and 8 plus 2 is 10. Here we did 5 plus 4 is 9, 8 plus 2 is 10. And so that's going to be the same for all of these points. So if I don't want to have to look at the graph, I can just say, okay, I'm going to add 4 to the X coordinate. So 5 plus 4 is 9. And I'm going to add 2 to the Y coordinate. 5 plus 2 is 7. And then I'm going to do the same thing for E prime, F prime, G prime, H prime. Okay, so 4 plus 4 is 8. And then 5 plus 2 is 7. Okay, it's always 4 to the X coordinate, 2 to the Y. So 4 plus 4 is 8. 2 to the Y coordinate, 7 plus 2 is 9. 4 to the X coordinate, so 3 plus 4 is 7. 7 plus 2 is 9. Three plus 4 is 7. And then 2 plus 2 is 4. And you can check them and make sure like we have them all matched up with that. Okay. So it says, what do you notice about the transformation of the graph in terms of the ordered pairs? And it's exactly what we just said. For the ordered pairs, what we're going to do is we're going to add 4 to the X coordinate and add 2 to the Y coordinates. So that vector or that rule tells us exactly what we're doing. Okay, and that's a translation.